Chandrayaan-3 was launched into space by the LVM-3 rocket from the Satish Dhawan Space Center in Sriharikota. Once in orbit, the propulsion module will carry the lander and rover configuration to a 100-kilometer lunar orbit. The lander will then separate from the propulsion module and attempt a soft landing on the lunar surface. The propulsion module also carries the spectropolarimetry of habitable planet Earth, SHAPE, payload, which will analyze the light from Earth to study its spectral and polarimetric properties. Chandrayaan-3 is a follow-up mission to Chandrayaan-2 that will attempt to land a spacecraft on the Moon and deploy a rover to explore the lunar surface. The rover will collect data on the composition and geology of the Moon, which will help scientists learn more about the history and evolution of our nearest celestial neighbor. In addition to its primary goal of landing a spacecraft on the Moon, Chandrayaan-3 will also conduct scientific experiments to study the Moon's environment, including its history, geology, and potential for resources. Chandrayaan-3 is carrying 6 payloads to study the lunar soil and capture photographs of Earth from the lunar orbit. During its 14-day mission, one lunar day, upon landing, Chandrayaan-3 will conduct a series of groundbreaking experiments using its payloads Ramba and Ilsa. These experiments will study the Moon's atmosphere and dig into the surface to better understand its mineral composition. The lander Vikram will photograph the rover Pragyan, which will deploy its instruments to study seismic activity on the Moon. Through this mission, India will not only access a wealth of knowledge about the lunar surface but also its potential for human habitation in the future. ISRO Chief S. Somnath said that a location near the equator is more likely to be suitable for human settlement. I don't know that aspect very well, which is the best place for human beings to go. You are talking from the point of view of the availability of water, and that is possibly one aspect. Today, one of the important requirements is temperature excursions, deviations, as well as availability of solar power for power generation. From that point, an equatorial location could be more ideal for human beings to settle, if at all a human habitat has to be built. Another payload, the radio anatomy of moon-bound hypersensitive ionosphere and atmosphere, Ramba, will measure the density of charged particles near the lunar surface and how it changes over time. Additionally, the Alpha Particle X-ray Spectrometer, APXS, will measure the chemical composition and infer the mineralogical composition of the Moon's surface, while the Laser-Induced Breakdown Spectroscope, LIBS, will determine the elemental composition of lunar soil.